Hi guys, today we will be discussing transport layer, which is the fourth layer in the OSI model. Okay, so in OSI model, above transport layer we have three layers: the application, presentation, and system. And below transport layer we have three layers, which are network, data link, and physical. So all the layers which are above the above the transport layer, what they do is they take the raw data from the user and they send it to the transport layer. Okay, so from the transport layer is where the network starts working. Now, transport layer maintains end-to-end communication between two devices. What does end-to-end communication means is from which application, there are two applications which are talking from host 1 to host 2, between two hosts. Okay, so transport layer will take care that whatever information which we are sending from an application in host 1 is received by the another application which is running in host 3. So this is what is called as an end-to-end communication. Okay, we are not sending the data only to the particular host. We are also taking care that in the host, if there are multiple other applications running, if there are multiple applications running, we are also taking care that our data goes to the correct application. Okay, so that is where the end-to-end application comes. And since there are multiple, since there can be multiple applications running on a single host, the transport layer will track all the different applications, and for them it will create different sessions, and it can communicate over that transport layer. But there are some lower layers which are network, data link, and physical. What they do is they encapsulate this raw data into some header. Using some header, they encapsulate this raw data and then they transport it over the transport layer. They send it over the transport layer. Okay. So why is there a need for encapsulation? Encapsulation is to add some extra information other than the raw data. Okay. So suppose we are adding IP addresses, we are adding port numbers, we are adding um, error bits to check if there is some error in the packet. So all of this forms the headers. Okay. So all of this is encapsulated. The raw data is encapsulated using this all of this extra information. Okay. So in the transport layer, there are two types of protocols which can run. One is TCP protocol and another one is UDP protocol. So there are many major differences between these protocols. One is TCP protocol is connection oriented and UDP protocol is connectionless. So what does the word connection oriented and connectionless mean? In TCP, between two devices, between two hosts, okay, we are maintaining a connection. So if any packet, if any communication is taking place, that is happening over that connection. Okay. In UDP, if we are sending a data from host A to host B, it is not sent over a connection. Okay. It can take any path. So you can see it like a tunnel. So TCP protocol makes a tunnel. Any traffic which is moving, it will take that tunnel. But in UDP, there is no tunnel. So the traffic can reach from any road. From host A to host B, it can go from any road. But if there is a tunnel between 2 points, then the car can go directly from that tunnel from host A to host B. So this is the analogy we can say where it is connection oriented, connectionless. Okay, and therefore, since in TCP protocol there is no in TCP protocol since there is a connection maintained, we have also a guarantee delivery of messages. But in UDP, since there is no connection, there is no guarantee that your message will be delivered. Okay, because there is no way in UDP to find out if the packet was lost. And if a packet is lost, which packet was lost? So TCP protocol, if any packet is lost, we can retransmit that packet. We can resend that packet. But in UDP, if any packet is lost, we cannot retransmit it because there is no way to determine which packet was lost so that we can resend it. Okay. So in TCP protocol, one major thing is it is very reliable. But since there is so much extra work to be done, it is a little bit slow than UDP. Okay. But UDP protocol, since it is a little less work to do, it is more faster than TCP protocol. Okay. So it is not so reliable, but faster than TCP protocol. Okay. So where are both used? TCP protocols is used in suppose in web browsers. Okay, where we are using HTTP. Since it should be reliable communication, we are using TCP protocol there. But in some real-time applications like video call or audio call, okay, where latency is more important than uh, whether the message is delivered or not, rather than the reliability, the latency is more important. There we can use UDP. Even if a packet or two is lost, it is okay, but that the data transmission should happen in real time. If I speak something in video call and the receiver will receive it after a delay, after a certain amount of delay, then it is not a good quality video call. Okay. So therefore, in such scenarios, UDP protocol becomes a good selection for the protocol. Now, tracking the devices, for tracking the services in transport layer, we have what is called a port number. So port number is a 16-bit number, okay, which can identify specific type of service or application which is running on a device. Okay, device we can identify using the IP address. Okay, and within that device, which application we are running, which application do the data need to be transmitted, that can be tracked using using transport layer. Okay, and the combination of these both, combination of IP address and ports, it is called a socket. Okay, so if we have the information about the socket, we can transmit data from one application in host A to another application in host B direct end to end. So this is where the transport layer comes to in the picture, end to end communication. Okay, now let's move ahead to the important part of TCP three-way handshake. Since we saw that TCP is a connection oriented protocol, so there needs to be a there is a need of a connection between two hosts. So this is protocol is useful in maintaining or creating that application of creating that uh, connection between two hosts. Okay, so there are three packets which are sent. First is SYN, then host 2 sends SYN ACK, then host 1 again sends ACK. Okay, so we can see that host 1 will send a SYN packet, TCP SYN packet, which will contain any random sequence number. Okay, it will send two data. One is acknowledgement and one is sequence number. So sequence number will be a random sequence number and acknowledgement will be 0. Then host 2 will reply. It will send its own sequence number, which will be any random sequence number, and it will send an acknowledgement. Acknowledgement will be the sequence number of host 1 plus 1. Okay. It will again send two information, that is sequence number and acknowledgement. So sequence number is again a random number and acknowledgement number is a sequence number of host 1 plus 1. The third packet is host 1 will send it again to host 2. It will contain a acknowledgement, and that will be the sequence number of host 2 plus 1. So you can see acknowledgement is the sequence number of the another host plus 1. So for host 1, it is sequence number of host 2 plus 1. And for host 2, it is sequence number of host 1 plus 1. Okay. So this is after transmitting all of these packets properly. Okay. After both of the devices have received them properly, this communication is completed. After this communication is completed, our TCP connection is completed. And after that, any other application can use it to send data over it, over this connection. Okay, so this is all about transport layer. Thank you.